In this example, we have the function g, which is translated is a translation of the parent function f, 2 units to the right and 4 units down. What's the equation for g? And write the quadratic equation in vertex form and standard form. So since we know it's a quadratic parent function, that means the f it's referring to is f of x equals x squared. This is that quadratic function. So I'm going to kind of give myself a little bit of a pattern here. Let's start with vertex form. G of x will equal possibly a number there, possibly a number there, it is squared, and possibly a number here. The transformations we have is just a translation, I guess. 2 units to the right, which means we're doing x plus 2, and 4 units down, which means we're doing y minus 4. There is no reflections or dilations, so there's no multiplication going on. Taking this information, we'll put the minus 4 here, because outside affects y values in the same way. And inside x opposite, so we'll put minus 2 right there. We don't need the space out in front because there is no dilations or reflections. So there's the equation in vertex form. Now we're supposed to write it in standard form, which means we just have to simplify this equation. So since we are squaring x minus 2, we write it out twice here. And then distribute. And there is a formula to do this a little quicker, but a lot of people tend to forget it, so I'm just doing it this way. So just distributing out. Bringing down my minus 4. And then we'll combine like terms. So negative 2x and negative 2x will make negative 4x. And then positive 4 and the minus 4 cancel each other out. So this is standard form. And that's it. So here we're supposed to graph the function f of x equals negative 2 times, in parentheses, x plus 3 squared, and then plus 1. This is a quadratic function, so we're going to use quadratic properties to do it. You could use the 3 points, negative 1, 1, 0, 0, and 1, 1, if that's more comfortable for you. But we are going to just use the vertex, and we'll use our dilation to actually finish graphing it. So, just getting our transformation rules first. Inside x opposite, outside y same. So we'll do x minus 3. And y times negative 2 plus 1. Normally the vertex is at 0, 0. We're going to apply the transformations to the vertex. So 0 minus 3 is negative 3. And 0 times negative 2 is 0, plus 1 is 1. So we have the vertex at negative 3, 1. Like I said, you can use the other 2 points for the quadratic if you wish, but we're going to just use our dilation directly. Now, important to remember that this is not slope. The way you use the dilation to graph is you just go over 1 unit in both directions and then go up or down whatever that dilation is. So I'm going to go over 1 unit in both directions, And then since that's a -2, we go down 2 to get my second points there and there. To finish graphing it, we'll draw a U shape in. Quadratic function is a U-shaped graph, so we need to make sure to draw U-shape in. Just to emphasize, if our dilation was a 1/2, we go over 1 and down 1/2. It's not slope, so don't treat it like slope. Yeah, we also have that reflection going on, which is why it's flipped downwards, since we are multiplying by a negative. That's it.